All righty. So what we're going to be talking about and discussing over the next day and a half or so, next 2 days, is what's called an annuity. So this is our, like financial supplementary lesson. And the reason that we're talking about this, if I can rant or be a little bit transparent for a second, some of the stuff that we learn, you're never going to use. Okay. Flat out. It's not necessarily useful. What we do in math class, and the reason that you take these courses and stuff like that, is to enhance your problem solving skills and your ability to critically think. All right. It's not that you're going to solve a logarithmic equation in your day-to-day life. It's not that you're going to solve or graph a polynomial equation in your day-to-day life. But what it helps you to understand is the visual component, the application component, the problem solving, critical thinking, logical reasoning, all that stuff that you're building up without necessarily knowing it. So with that being said, we're going to take a second to now talk about an application and an idea that is useful for you to know as it relates to finance and stuff like that, and ties in with some of the ideas that we discussed before. So you might not use that process all the time, but this is kind of a supplement to some of the processes we talked about in previous sections and stuff like that. All right. What that topic is what's called an annuity, and specifically finding the future value of an annuity. Now, this idea, this term might seem new to you. Essentially, what an annuity is a series of payments made at equal intervals over time. It helps you to grow money, whether that's happening positively for you, like a retirement plan, pension fund, stuff like that, or somewhat negatively with like mortgages and stuff. So we understand that like whatever you buy your house for, and this is key, you can back me up on this one. Whatever you buy your house for will eventually be higher in value, right, with your payments and stuff like that. So it's not like, oh, I took a loan out for this, like you're paying more, right? Just like anything else, right? So this is very applicable to something that you're going to encounter at some point in your life, all right? So a series of payments. What are some types of annuities? Deposits into savings accounts, monthly home mortgage payments, like we just talked about, monthly insurance payments, and pension payments, or like retirement funds, things like that. All right. And we're going to discuss some advantageous ways that you can take advantage. You can obviously take advantage of annuities and stuff like that. How do I calculate it? Well, this is the formula that we're going to use. Now, it looks a little bit daunting, although when we took care of compound interest, we were able to just do it step by step, figure everything out, and we have to use our order of operations to kind of help us out with that, similar to annuities today. All right. So all of these variables here stand for something. In fact, a lot of them are very similar to when we talked about compound interest. FV is just called the future value. All right. So we're finding that total amount, that lump sum in the end. All right. P is the amount of payments that are made over time. So for example, say you want to take money every month out and put it into something, that's that amount that you're taking out is the payment. That's going to go in for P. R is your interest rate. So just like what we talked about before with interest rates, like that way that it's going to grow. And that's always in terms of a decimal. So it's going to be given as a percent, got to convert it to a decimal. N is the number of times it's compounded. So if something's compounded annually, how many times does it happen? Once. Semi-annually, quarterly, monthly, so on and so forth, right? So we're going to need to remember some of those terms and how they apply. And then T is the amount of times the annuity is being paid into. So over the course of how many years, how many months, whatever it may be, whatever the situation exists. All right. So that's kind of a very loose introduction into annuities and stuff like that. Does anybody have any questions about that idea? So we're going to take a look at 4 examples over the course of today. I'll kind of just do the first one on my own so we get a good grasp of how to go about these problems. Then we'll do the next 3. Probably useful to have a calculator or at least your phone to kind of help you out with these in case I ask for any kind of, calculation. It'd be useful for you to tell me instead of having to do everything. But just make sure we're paying attention to this process. We'll go through some examples and hopefully you gain some kind of knowledge or understanding about what's going on here. All right. So first one says, what is the future value of an annuity that makes annual payments of $5,000 compounded quarterly at an interest rate of 7%? And for those of you that are at home, I added in over the course of 10 years. For those of you that are in here, you have that in front of you. All right. So what is the future value? If I'm going through, the first thing I want to do is start by assigning values to each of my variables. All right. Future value is something that I don't know. So I'm going to put a couple question marks in there to understand that that's what I'm solving for. I'm making these payments of $5,000. So each time that I'm making a payment into this, it's $5,000. All right. At an interest rate of 7%, 7% I'm going to convert to a decimal. So it's going to be 0.07. Remember, our percentages are all out of 100. So it's the 100th place of our decimal. This is happening quarterly, that it's being compounded. So it's 4 times a year over the course of 10 years. All right. So $5,000 payments at 7% interest rate, compounded quarterly over the course of 10 years. After we assign variables, values, now what we're going to do is take that and plug it into our equation. Like I said before, we're going to have to use our order of operations to kind of help us. Take it step by step. Don't try to do too many things at once. Okay. So if I'm doing that, I have FV is equal to, in for P, I'm going to plug 5,000. And I'm multiplying that number by this entire thing. So really, if you wanted to, this entire thing here can be in parentheses because you're going to take care of all of this first. All right. Then I have 1 plus 0.07 divided by 4. This whole thing raised to the n times t. So that's what's taking place up there. So that number n, 4 times t, which is 10. Don't forget the -1 here on the outside of your numerator. Then you're going to divide that through by r divided by n, which is 0.07 divided by 4. All right. Everybody with me so far? So now what I would suggest to do, like I said, do it step by step, but take care of what's in your numerator first and then work with your denominator and then kind of work with those values separately. So evaluate everything that's inside your parentheses here. So to deal with this fraction, add 1, raise it to an exponent, subtract 1. All right, that's kind of your steps each time. So if I do that, I have 0.07 divided by 4, it's 0.0175. And then I'm going to add 1 to that. So I'm taking care of everything in my numerator here, but inside my parentheses. So I have 1.0175. Raised to the 4 times 10 power, which is the 40th power, minus 1. And then notice that 0.0175 is also going to go in my denominator because that's 0.07 divided by 4. All right. So 0.0175. Okay. Now I'm going to simplify this. So if I simplify my numerator, 1.0175 to the 40th power, it's 2.00159, whatever. And then I have to subtract 1 from that. I get 1.00159, so on and so forth. Let's just round everything to the thousandth place just to get a little bit more of an accurate idea. So 1.001. All right. So when I raise it to the 40th power and then subtract 1, everything that's going on in my numerator, I get 1.001. And I'm dividing that by 0.0175 and then multiplying by 5,000 to find what my future value is. 1.001 divided by 0.0175. Before I do this, I just want to make sure, does anybody have any questions up until this point? I know I'm kind of moving through this a little bit quicker. Everybody good? Gives me 57.2. And when I do 57.2, so that's what came out of this, times 5,000, I get $286,000. Okay. $286,000. So 4 times a year, you put in these $5,000 payments. It's compounded over a certain amount of time. This takes place over the course of 10 years, this interest rate, and you get $286,000. Well, here's the reason why we're talking about this. All right. So cool. We just found the number. So what? So if you were to take $5,000 and just put it aside, so not even putting it into something, not into this particular account, this annuity, whatever it may be, right? Every 3 months, so 4 times a year, you take $5,000 and you put it aside. Well, over the course of 10 years, that's 40 times that you're doing this. And your final value is $200,000. So the lesson behind all of this is that putting it into something that's going to allow it to grow just gave you $86,000 more than if you just put it aside in your, savings, or you put it aside in a drawer somewhere. Okay. So it's useful for you to take your money and continue to put it in something that's going to allow it to grow rather than just putting it off to the side. Does that make sense? So if you walk away with one thing from today, hopefully it's that. All right. So there you go. Any questions about that first example? All right. Example 2. What is the future value of an annuity that makes $750 payments compounded semi-annually at an interest rate of 5.5% over the course of 20 years? All right. Why don't you help me, after reading through that, assign each of my variables of value? So do I know my future value, or is that what I'm solving for? Right. So I don't know that. What is my payment? So what's going to be the value for P? 750. My interest rate, 0.055. Good. So I'm changing it from 5.5% to 0.055. Okay. How many times is this happening per year? 2 times, because it's semi-annually over the course of 20 years. All right. So always start by assigning your variables some different values to work with. Okay. Now we're going to plug those values in. So I have 750 times 1 plus the rate 0.055 divided by the number of times, which is 2, raised to the 2 times 20 power minus 1. And this is all being divided by 0.055 divided by 2. Okay. Everybody with me so far? What's 0.055 divided by 2? Somebody help me out with that. 0.0275. And if I add 1 to that, it's 1.0275, right? So my next line, I have 750 times 1.0275 raised to the 40th power minus 1 over 0.0275. Right? Remember that you add 1 here in the numerator, not in the denominator. So these numbers should be just 1 off from each other. And now what I'm going to do is simplify everything here. So I have 1.0275 to the 40th. Gives me 2.959873, so on and so forth. Subtract 1 from that. 1.959873. Why don't we round this to the nearest thousands? So it's going to be 1.960. All right. In my numerator. Divided by 0.0275. Anybody have a value for that? 71.27. So 750 times 71.272. We'll just go to the thousands to be consistent. And when I multiply those numbers together, so 71.272 times 750, I get $53,454. All right. So again, we can do the same thing that we did in the last example. Before we do that, though, does anybody have any questions about how we got this value? So if you just did $750 payments twice a year, that's $1,500 times 20. 1,500 times 20, which is 30,000. Notice the difference between 30,000 and 53,000, right? So put it into something that will allow it to grow. Very similar to the first example. It was an $86,000 difference. This example, it's a $23,000 difference. Right? You're setting yourself up for later down the line. It's going to make a huge difference. Okay. Any questions about that example? All right. What I want to do, just for the sake of time, I want to make sure we should be able to get through both examples, but I want to make sure that we have enough time to do this one because it's a little bit of ownership for you. Does anybody have an idea of what they want to do for a job? A little bit? Yeah. Is anybody willing to share what that is? Criminal lawyer? Okay. What's that? Detective and a criminal lawyer. All right, cool. So actually, why don't we just do it? No, we'll pick one of them. You guys want to rock, paper, scissors for which one we pick, or does it matter? Let's go with criminal lawyer. See what that looks like. All right. Or you know what? Now I'm actually curious. Let's go with detective. All right. Average. Let's go. All right. Bureau of Labor Statistics. Average salary of a detective. Say FBI detective, right? So that's a median, which means that people start lower and people are much higher. Okay. So Says median annual wage of police detectives was $67,290. Median wage is half the workers, so on and so forth, whatever. Highest 10% earns $113,860. So why don't we like split the difference a little bit and let's call it like 80. Call it 80 grand. All right. So we'll say you're a veteran detective, but you're not at the top yet. All right. Sound good? So we chose detective. All right. And they say that detectives, we're going to take a little bit more than the median, and we're going to say that you're making 80 grand a year to be a detective. All right. Not quite. So we'll get there in a second. So we picked this, we picked the job, right? We understand what our salary is per year. What we're going to do is find out what the monthly salary would be. So let's just do this step by step. So monthly salary, 80,000 divided by what number? 12. And what is that? Right. Yikes. A lot of sixes. Very ugly number. So why don't we pick $6,670? So monthly. Actually, here's a lesson. It's going to be $6,050 or $6,500 because of taxes. And if you can only get taken $116 or $166 out in taxes, you have a pretty sweet life. So we'll just pick 6,500. Okay. So that's what you're making monthly to be a detective. It says, what is the future value of a pension plan? So I would imagine the FBI has a pretty sweet pension plan where they're getting a nice little retirement fund there at the end. Pays 15% of your monthly salary. All right. Some plans might be lower in percentages depending on what the job is and stuff like that. So we're going to take 15% of our monthly salary, essentially, put it away. It's going to be compounded quarterly at an interest rate of 6.5% over the course of 35 years. So you serve 35 years for the FBI. So whatever that number is going in the payment, right? So what we did is we started with the yearly salary. We found what would be monthly. And then we're taking this number now, the $6,500, that monthly payment that you're getting. And we're taking out 15% of it. So multiplying it by 0.15. All right. And it's $975. So 6,500 times 0.15 gave us the $975. And Jenna, as you said, that's going to be our payment each month. So we're trying to find what that future value is. But our monthly payment is $975, or our payment each time is $975. The interest rate is 6.5%. What's that as a decimal? Good. Happening quarterly. Let's change that to monthly. All right. So let's make it monthly. So we have 12 over the course of 35 years. All right. And now what we're going to do is plug these values in and solve. So I have future value equals $975 payment, 1 plus 0.065 divided by n, which is 12, to the 12 times 35 minus 1. Take a second to jot that down. Make sure everybody's on the same page here. All right. And then we'll just take this step by step again. So we'll do 0.065 divided by 12. 0.005, we'll call it. And we'll add 1 to that. So it's 1.005. 12 times 35 gives me 420. So I'm taking that 1.005, raising it to the 420th power, subtracting 1, and then dividing it by 0.005 again. Okay, let's go through and do that. 1.005 raised to the 420th power. 8.12355, so on and so forth. Subtract 1, and then divide that by 0.005. I get 1,424.71. Now, whether this exists out there in the real world or not, with it being compounded that many times and so on and so forth, 975 times $1,424.71, or 1,424.71, is roughly $1,389,000. $92.25. So what I did was adjusted it to monthly. The more times it's compounded, it's gonna allow it to grow, right? So if you just make it quarterly, you're losing out on 8 payments per year. So it's a little bit different, right? Right. So if you, depending on how you round it and stuff like that. Right. Also, you have to be able to take out $975 a month to be able to get to that point. So that is accomplishable. It is very real. But at the same time, too, like you got to think about the rest of your life expenses and things like that, which is actually something we're going to talk about tomorrow. Because the ability to put $975 away each month is very, I don't know if that's, it's attainable for some people, but very tough. I would say it's very tough. All right. Any questions about that example? I wanted to give you a little bit of a, some accountability there. You get to choose your own job, figure out this stuff. So if you can put away $975 a month into this account and you find this account, $1.3 million waiting for you when you're done being effective. Interesting stuff. Any questions about that example? All right. We have time for the last one, but I did want to make sure we got through that one first. So flip back over to number 3. And now in this example, it's going to be a little bit different because now we're trying to find the payment each month. Instead of finding the future value, well, what's the payment going to be in order to pay off that future value? All right. So it says a bank loans a family $300,000. How much should the monthly mortgage payment be over 15 years if the interest rate of the house is 5% and it is compounded monthly? So talking about these monthly payments, for those of you that are at home, I changed it to 300,000 in case you're looking at your own sheet. So what should go in for future value? 300,000. Monthly payment, we don't know, right? What's my interest rate? 0.05. It's happening how many times a year? 12 over the course of 15 years. Mortgage plans, for the most part, correct me if I'm wrong, 15 or 30 years. More than likely it's 30. I guess it depends on the property. Right. For the sake of the problem, I chose 15. But it is a possibility, right? To use 15, but more, it's a better choice to do 15. Well, you get it out of the way. Right. Okay. So there you go. More different mortgage plans, depending on properties, depending on, I guess, finances and what you can take care of. And we're going to try to find this monthly payment. All right. So, down the line, maybe you're comparing two houses. You want to settle on one of them and you're not sure what the monthly mortgage payment is going to be and what's going to be most cost beneficial to you. Pull out this problem and figure it out. So, yep. Don't say I never taught you anything. So you have $300,000. P is what we don't know. 1 plus the rate is 0.05 divided by the number of times, which is 12, raised to the 12 times 15 minus 1, all over 0.05 divided by 12. Okay. Give you a second to jot that down, and then we'll get started. All right, what's 0.05 divided by 12? Somebody help me out with that. 0.004. We add 1 to that, we get 1.004. So I have 30,000. Do a P times 1.004. 12 times 15 is 180. Divided by 0.004. Again, remember the 1 is going to be up top. You're not adding 1 or anything down below. (1.004) raised to the 180th power gives me 2.051484, so on and so forth. Subtract 1. I get 1.051 up top. Divided by 0.004. This is all still equal to 300,000. (1.051 divided by 0.004 gives me 262.75. And what do you think I need to do on both sides to get P by itself? Right, divide each side by 262.75. Good. So if I do 300,000 divided by 262.75, that payment each month is $1,141.77. And that's what you have to pay each month for your home. It's pretty decent amount, I would say. I mean, I don't own my own house. Ms. Q, is that a high mortgage payment?
Well, actually, not as high as, but then you
pretty relative, right?
It's kind of relative, but you're not just paying that, just for real labor.
Right. Because then you have to pay taxes.
And insurance fees.
What's that? Right. So, yeah. Right. Keep in mind that, I mean, if you have a significant other or a husband or wife, I mean, that helps too. So you're not dishing all that out on your own. But that is the last problem. So hopefully you took away, some kind of, fact related to all this, whether it's to put your money into something that's going to help it grow, understanding how you might be able to calculate and compare, mortgage payments, things like that. Did a little bit of fun activity with the, choosing your own profession and choose your own adventure problem. All right. Which is kind of what leads me into what we're going to do tomorrow. So for tonight, that's all for today in terms of, the lesson, stuff like that. There's no homework or anything. But if you go into tomorrow's folder, so that's it for today. Like I said, no assignment. Tomorrow, what we're going to do, just to kind of give you a heads up, is very similar to that fourth problem, except it's going to require even more participation throughout the entire day. So what we're going to do, and I think it's pretty applicable to everybody, is we're going to start similar to what we just did. We're going to choose our own profession, and we're going to try and understand what our monthly income is. Then we're going to choose a school to go to, and we're going to see, well, how much debt am I going to be in for that? How much student loans, because student loans require interest. So we're going to talk about compound interest again. Choose a place to live. So we got to be a little bit strategic there, depending on what profession we choose and stuff like that. Understand our finances and how much we need to pay. And then that life stuff that you said, car payments, groceries, insurance, social expenses, things like that, we'll take into account. And after all of that's added and subtracted, what we'll do is we'll figure out, okay, well, how much is left over for me to invest in myself, invest in my future, and put away for, later down the line. Is this applicable to your 17-year-old life right now? Probably not right this second, but at least you can kind of understand that money doesn't grow on trees. And there's definitely a lot that you need to take into account as you progress through your life and get a little bit older. All right. Any questions about what we did in class today or the plan for tomorrow? Anything moving forward? Okay. With that being said,